Good evening. In the last video, we covered very clearly about priority queues. Today, we are going to wind up this priority queues. So what is mean by priority queue? How this priority queue is implemented by using heap data structure, this priority queue was implemented. And we have seen very clearly how we can able to work with that heap data structure when we can say a tree is in heap, when we can say a tree is in heap. Suppose if it is not satisfying the heap properties, what we have to do? This entire story we discussed very clearly in the beginning of the class. Next, and after that, how to add an element into the how to add an element to the heap and how to remove an element from the heap. That part also we discussed very clearly in our last session. And even we implemented the program also. So manually we have created a heap and we executed that process. So how priority queue is going to work? In the same style that heap tree is also worked, sir. Now, the application of this priority queues is nothing but heap sort. Heap sort. We know very well about the sorting technique, right? So here we will sort the elements in ascending order. If you want to do ascending order, sir, which element should come first? Minimum element, right? Then I'm going to apply max heap. So if you apply max heap, then what will happen? Consider I have a tree like this. So 1 and its left subtree will become 2 and its right subtree will become 4 and this left subtree will become 5 and this right subtree will become 3. If you have a tree like this, we will perform max heap operation. That means 5 will come to the top, remaining elements will be there here. Okay, remaining elements will be there here. Of course, it is not the correct tree, just for your understanding purpose I am telling. So we will find out this 5 and we will push this element to the last. Then remaining elements are there, right? For this again max heap I am going to perform. So 4 will come. That I am going to push to this last P4. So once if you remove 4, then 3 elements will be there. So 3 will become max heap. So that is root element. Then we are going to push that. So next we will have only 2 elements. So 2 will become next maximum and only one element is there like this. So if you want to arrange the data in ascending order, you have to perform which operation? Max heap. And opposite for this, right? If I want to arrange the elements in descending order. So we have to apply which algorithm? Min heap algorithm we have to apply. So if you apply min heap, then same tree, right? We are going to get so 1 and then 2 and then 4 and then 5 and then 3 are there means. So first 1 will be stored at the end. Okay. Next remaining elements, try to apply min heap so that 2 will come next. So we have to push that to this last 2 before. Next we have 5 3 4, apply min heap, 3 will come at the top, we have to push that. So then we have 5 and then 4, apply min heap, we will get 4. Then only one element is there, 5. That's all. This internal modification we will do in the array ARR itself. Okay, we will do this modification in the array ARR itself. But how it will be, we are going to discuss in detail, sir. Okay, how it will be, we are going to discuss in detail. I think the concept of this heap sort is very clear for you people. Please confirm if this theoretical concept is clear for you people. How we can implement this algorithm, I will explain, sir. Can you please confirm everyone? Is this concept is clear for you people? Yeah, don't worry. We will see that algorithm. That algorithm will explain how we are going to do this sorting. Okay. I request everyone to please confirm. Is it clear? Right. So how to implement that heap sort? How to implement that heap sort? I'm going to take main method. So in this only, I will call heap sort. Sir, to sort the data, to sort this heap sort, okay, I will write main function later. Public static void, I'm taking heap sort. In which order you required? In the ascending order you required. Okay, in the ascending order you required. So here it is receiving one array A. Let us assume that array is nothing but A. Sir, there are two steps are there. What is the first step, sir? We have to build. We have to build max heap because we are working with ascending order. What is a step two? We have to push the largest element. We have to push the largest element at the end. These are the two operations. Sir, to build max heap, I'm going to find out the length of this array. How many elements are there in that array? And then for each I is equal to n by 2, I greater than or equal to 0, I minus minus. Sir, I'm going to call one special function called heapify by passing a comma I comma n, by passing a comma I comma n. But how this heapify is going to work, I will show you. Sir, after this, which operation we have to perform? We have to move the element to the last. For I is equal to n minus 1. That means last before element, I greater than 0, I minus minus. Sir, what operation we have to do? We have to swap, right? Okay, we have to swap. Which one? Sir, you need to store in the temporary variable. I will take a temporary variable. In that temporary variable, I am going to hold a of 0. That means first element, I am going to store it in temp. So where you have to move this to the last, right? That's why a of I will become, sorry, a of 0 will become, so a of I. Okay, then your a of I will become temp. Your a of I will become temp. So then again I am going to call this heapify function by taking a comma 0 comma 1. Like this we are going to take. This is nothing but the approach what we have to follow. But don't worry, how it is going to work in detail I will explain. Okay, how it is going to work in detail I will explain. Sir, now I am going to take one example, sir. I am going to take one example. Let us consider the example as, let us consider the example as, so one, yes, here I am taking that example. So one, okay, next and after that its a child is 2 and its another child is nothing but 4. So its another child is nothing but 3, sorry, let me take a 5, and its another child is nothing but 3. Okay, like this we have, this is nothing but my tree. So what we have to do? What is the first operation? The length of the tree is nothing but how many elements are there? 1, 2. If you want, let us write array representation of this tree. So this is 0th location. This is the first location. This is the second location. So this is the third location. Okay, 1, 2, 3, 4, 5 elements are there. This is the fourth location. Internally, the elements are in 0th location, we have 1. In first location, we have 2. In second location, we have 4. In third location, we have 5. In fourth location, we have 3. Like these elements are there. Now, what is the n value? N is nothing but 5, sir. Okay, n is nothing but 5. For I is equal to n by 2, 5 by 2. 5 by 2 is 2 and I greater than or equal to 0. That means what are the values of I we are going to get? We will get I is equal to 2, I is equal to 1, I is equal to 0. Have you observed? Except the leaf nodes, remaining things I am going to concentrate. Except leaf nodes, remaining things I have to concentrate. Sir, why? Because leaf nodes is not having any children, right? That's why we are going to ignore for this heapify operation. Anyway, from here only it will be their comparison. I will show you how it is going to compare. So after that, I'm going to call heapify function. So heapify of that entire array I value. I value means what? Here I am taking 2. I value is initially 2. So based on this 2, I'm going to call, okay, heapify function. I'm going to call this heapify function. Sir, what that heapify function is going to do? We are going to discuss now. Observe carefully that heapify function. So it is going to take array as the index, which is nothing but array. I value is nothing but 2. And what is the size? 5. Like this we have. Sir, here this I is nothing but index, sir. It will find out left value. For I is equal to 2, I am taking left. What is the formula? 2 into I plus 1, right? 2 into I value is 2. 2 into 2 is nothing but 4. 4 plus 1 is nothing but 5. Next, I am calculating right value. Right value will become 5. 2 into 2. 4 plus 2 is nothing but 6. Like this, we are going to get. Sir, we have to find out maximum index for this. We have to find out maximum index for this, like we have done in the previous case. I am going to take the given index as the maximum index. Now check whether left is less than n. Sir, is 5 is less than n? Is left is less than n? Is 5 is less than 5? No, it is not satisfied. Then is right value 6? Is it less than 5? No, this condition is also not satisfied. Okay. And is there any swapping is required? No, no swapping is required. Okay. Now observe carefully. I am checking for I is equal to 2. Swapping is not required. So here 2 and then 2. If you are getting both values as the same, swapping is not required. Sir, for I is equal to 2. Now for I is equal to 1, I am calculating. For I is equal to 1, I am taking. Sir, your left will become, so 2 into 1, that is nothing but 2, plus 1 is nothing but 3. Right subtree will become 4. Now minimum index is nothing but the same as the original I. Now you have to check. Sir, is your left value is less than n? Yes. Then what we have to do? You have to check a of left, that is nothing but a of 3. Is it greater than a of 1? Sir, a of 3 means what? This one, right? 0, 1, 2, 3. This one. I am comparing this a of 3, 5. Is it greater than a of 1? That means what? 1, 2 here. Is 5 is greater than 2? Yes, 5 is greater than 2. Then what we have to do? We have to take max index as left. What is the max index, sir? Here, left. What is the left value here? Left index is nothing but 3. Now, this is nothing but the maximum index as of now. Similarly, you have to check for right index also, right? So then what we have to do? So a of right value is 4. Is it greater than? Now maximum index which I got is nothing but 3. So a of 4 is nothing but 3. Is it greater than a of 3 is nothing but what? 5. So condition is not satisfied. That means my maximum index, maximum value is available in third index. Sir, we have to swap which one? Max index and then this a temporary variable, that is nothing but I. So first location, third location we have to change. Sir, here we will get 5. So here we are going to get 1. Like this we are going to do. This is for I is equal to 1. Okay, this is for I is equal to 1. Of course, we are going to repeat this process. Okay, we are going to repeat this process for all the values. This 5 value got interchanged with 1, right? So this value is going to be repeated for all the right subtrees, all these things. I will show you how it is going to be recursively called. Okay, can you please confirm, is the small code, is it clear for you people? In this case, we are doing only max heap. Can you please confirm, is the concept is clear? Yes, I request everyone to please confirm, sir. How we, this process already I explained in the last video, how we are going to do this. Right. Sir, what is the next step? So this process has to be repeated. This process has to be repeated. I will write that code also, heapify code, then you will get a clarity. So public static void, I am taking heapify function, which will take integer array a comma integer index value and then the length of the array. Like this I am taking. So now integer, your left will become, so 2 into I plus 1. Integer, your right will become, so 2 into I plus 2. Integer, so I am finding max index. Max index is nothing but I. Then I am going to check, is your left value, is it less than n? And So A of left, whatever we have, is it greater than A of max index or not? If this condition is satisfied, your max index will become left, sir. So else I am going to check, is your right value, is it less than n? And A of right is there, right? This A of right, is it greater than A of max index? I am checking. If this condition is also satisfied, then your max index will become right. Like we are going to identify the max index, and if your max index is not equal to I, if your max index is not equal to I, then we have to perform as usual swapping operation. Integer temp will become A of I, and in the place of A of I am taking A of max index, and in the place of A of max index I am going to hold temporary value. That's all. Then again we have to call this heapify by passing A comma, so 0 comma I, sir. Again we have to pass these values. Why? Because it has to be repetitive process. You need to find out for each and every node. Sir, in this example, how it is going to be called for a second time? For this continuation, it is going to call for the same function will be called. Now what will be your I value? 0. I think, is it 0 or some other value we have to pass? Okay, if you pass 0, then what will happen? Your left subtree will become your left subtree. I think same process we are doing. Okay, we will check. Okay, so this is nothing but the algorithm what you have to use for heapify. So this heapify is going to do this process repeatedly, so that all the elements are going to be sorted. At last, I mean, we are going to get a maximum element at the top. Okay, we are going to get a maximum element at the top. Then what we have to do, we are taking a for loop to push that max element to the end. So how we are going to take I is equal to, so n minus 1. What is the n value? 5. 5 minus 1 means 4. We are starting from fourth location onwards. So your temp will become A of 0. What is the A of 0? 5. Try to store A of 0 is equal to A of 5. So in A of 4, 3 is there. That I am going to store here. Then in this place, I am going to push 5. I am going to push 5. Then I minus minus. Your I value will become what, sir? 3. So that means again we are going to call this heapify for these elements. Why? Because see, whenever you are removing one element, compulsory you have to do heapify. In this case, we have to do heapify. At the same time, in this case also heapify you have to do, because it is a recursion process. Once if you are doing one element removal operation, the entire tree is going to be unstructured. Now the same process will be repeated for this. So now which element will come first? Next one, 4. That 4 we will move to the end. Then you have to do this process for this. Next this process. Next this process. So until I greater than 0, when you are getting nasty element, we are not required to perform. Just I will run this code. But if I want to run this code, what we have to do? We need to fill the main method, right? Let us take in the main method, I am taking one integer array with already given values like 1, 2, 4, 5, 3. Like this I am taking, and I will print before performing this heap sort what are the data. Okay, so I am taking arrays dot to string of A I am taking. Okay, so that my values will become 1, 2, 4, 5, 3, like this I am taking. Then so I am calling which function? Heap sort in ascending order, where you have to take A we have to pass. Okay, then after this, system dot out dot println of, again I am taking, so arrays dot to string of I will pass array. Definitely these elements should be arranged in ascending order. Let me check whether this algorithm is working properly or not. Whether this algorithm is working properly or not, just have a look once. Now you can able to see. So initially 1, 2, 4, 5, 3 we have given. Later after performing sorting operation, we got 1, 2, 3, 4, 5. This is nothing but how we can able to work with heap sort in ascending order. Can you please confirm everyone, is the concept is clear for you people? In the last class, how we have done heapify, same code only I have taken there. Okay, same code only I have taken there. But in addition to that, I passed the array. That's all. Beyond that, nothing. I request everyone to please confirm. Is it clear for you people? Right, Swapnil, please confirm. Right, right. Sir, I want to do this in descending order. What we have to do? If you want to do this in descending order, okay, I'm changing the function name as a DESC. What modification we have to do? What modification we have to do? So DESC, observe carefully. To build which heap we have to take? Min heap. So process is the same. N a dot length. I'm going to apply heapify function. So we have to push smallest element at the end, sir. So in the heapify, we have to do the modification. What is that modification? If a of left is less than max element, so is a of left is less than max element. I think in the place of max index, better to take min index. So I think that will be sufficient. Let me check. So wherever max index is there, there you have to fill min index. So except that there is no change, I think so, but let me check. Sir, is it printing minimum element or not? Yes. Every time it is trying to identify the minimum element and it will bring to the root. That is the first step. Second step, we are moving that element to the end. Whenever you are moving to the element to the end, the element which is available at the ending will come first. Is it satisfying my heap property? Definitely no. Then again we have to do this process repeatedly. I think the concept of doing this in descending order also, it is very clear for you people. Okay, so this is nothing but heap sort, ascending order and then descending order. Okay, I'm not going in detail into this. So with this, priority queues story has been completed. So clear up to this? Please confirm everyone. Is it clear? Sir, I request everyone to please respond, the people who are there in the session. Right. So with this, priority queues got completed. Sir, just I will give some brief introduction about this divide and conquer, because already we have completed this. Just a basic terminology I will provide. So divide and conquer, name itself is giving clarity. What is this divide and conquer? Sir, in divide and conquer, okay, in divide and conquer, we will break the problem. We will break the problem into sub problems. We are going to break the problems into sub problems. So then we have to solve sub problems. We have to solve sub problems. We have to solve sub problems independently. We have to solve these sub problems independently. One by one, we have to solve these problems, sir. Then we have to combine the solutions. We have to combine the solutions to get a solution for main problem, right? If you solve these problems individually, we will get a solution for main problem, sir. We will get a solution for main problem. Once if you got a solution for main problem, there ends our task. Then we have to solve these problems. We have to solve these sub problems by using recursion. Compulsory we have to use recursion concept to solve these problems, sir. Okay, and it has three forms. This divide and conquer. So this divide and conquer has three forms. What are those three forms? The first one is nothing but divide. What is the task of this? It is going to divide into smaller instances. What is the second step? Conquer. In the case of conquer, what we are doing? we are going to solve. Okay, we are going to solve sub problems. We are going to solve sub problems recursively. Recursively we are going to solve. Okay, sir, next and after that, third one is very, very important. We have to combine the solution. Okay, we have to combine the solutions of these sub problems. This is nothing but the strategy what our divide and conquer algorithm is going to follow. Okay, no, dynamic programming is different from this divide and conquer. Dynamic programming I will explain, don't worry. Sir, can you please confirm which algorithms? Already we discussed divide and conquer very clearly, sir. Now you have to tell me which algorithms will comes under this divide and conquer. Can you please confirm, everyone? Which algorithms will comes under this divide and conquer? I will list out. Yes, very good. Someone is telling merges are good. Next. Yes, we have binary search is there. Very good. Next. Still any other? Yes, any other? Binary search, very good. So quick sort also will comes under this category. Next, any other? So we have towers of Hanai. It is also solved by using recursion, right? So these are the strations, matrix multiplication, promote, correct. So all these things will comes under divide and conquer strategy. Okay, all these things will comes under divide and conquer strategy. So that's all, sir. I already explained about these things in our previous sessions itself. I'm not going to continue this in detail. Okay, so that's all about today's session. Tomorrow we are going to talk about greedy algorithms, dynamic programming. Greedy algorithms, dynamic programming, these two I will cover tomorrow. And time complexity is a pending topic. And red black trees. So red black trees, and I am revising that AVL trees also, because another batch is pending for that. AVL trees and red black trees I am going to cover as an optional special class I am going to take. In that I will cover these two. So tomorrow at as usual 7 o'clock I will take greedy algorithms, and I will finish some one or two applications related to the greedy algorithms. Okay, so this is nothing but our pending topics. With that we are going to wind up our session. Actually I plan to close by this week, but due to some emergency works, so it got postponed. So don't worry, maximum by next week we will wind up. Okay, I will give the date, maximum by Tuesday or Wednesday, like that. Okay, yeah. Yeah, I will look into that, Swapnil. If possible, I will cover. Okay. Yeah, okay, no problem. No problem, Buyan. You can watch the recordings. Yeah. Thank you. We will meet for the continuation tomorrow, sir. Thank you.